Good afternoon, all of you, my dear children. How are you? How are you, my dear children? Yes. Are you writing the classwork notes? Are you writing the classwork notes? Yes. Have you submitted your classwork notes in the Google Classroom? This week I will check and I will list out who are submitting the classwork notes, on which date they have submitted. I will list out. Okay, my dear children. Now, today we are going to discuss new chapter, that is complex numbers and quadratic equations. Complex numbers and quadratic equations. Please watch this video, my dear children. I am presenting a video on the concepts of complex numbers. Okay, please watch the video, my dear children. Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss the concepts of complex numbers. Are you ready to listen the class, my dear children? Right. Now let us discuss about the imaginary unit. What is meant by imaginary unit? See here, you can't take the square root of a negative number. Can you find the square root of a negative real number? Not at all. You can't find the square root of a negative real number. If you use imaginary units, you can. Okay, my dear children? Yes. The imaginary unit is I. This small letter I denotes square root of -1. Okay, my dear children? I is equal to square root of -1. Throughout this chapter, remember this point. I is equal to square root of -1. Okay, my dear children? This is called imaginary unit. It is used to write the square root of a negative number. This small letter I is used to write the square root of a negative number. See here, this is a radical sign. Do you remember that one? Radical sign. In this radical sign, this number is said to be index, and the number inside the radical sign is said to be radicand. Do you remember these points, my children? You have learned these points in your earlier class. Okay, my children? Right. Now, property of the square root of negative numbers. How can you denote the square root of a negative number? Suppose if r is a positive real number, then square root of -r is written as I into square root of r. Understood this point, my children? If r is a positive real number, then square root of -r is written as I into square root of r. For example, to understand this point, let us take some examples. Square root of -3. Here 3 is a positive real number. Then square root of -3 is written as I into square root of 3. Understood, my children? Similarly, square root of -4. Let us take this number. How can you denote? That is equal to I into square root of 4. That is equal to 2i. Understood these two examples, my children? Right. Now come to this point, the powers of I. What is the values of different powers of I? Okay, my children, you know that I is equal to Yes, is this point clear, my dear children? Square root of minus 1. What is the square root of minus 1? How do you write square root of minus 1? How do you write square root of minus 1? Small letter I. Square root of minus 1 is equal to small letter I. Throughout this chapter, remember this point. I is equal to square root of minus 1. Okay. Square root of minus 1. In the previous slides, we have discussed this point, my children. Remember this one throughout this chapter. Then I square is equal to minus 1. What is the value of I square? Minus 1. Then I cube is equal to, how can you write I square into I? Can we write it or not? Yes. Then I square value is minus 1. Minus 1 into I, minus I. Understood this value, my children? Similarly, I cube. How can you write I square whole square? I power 4. How can you write I power 4? I square whole square. What is the value of I square? Minus 1. Minus 1 whole square value is 1. Understood these values, my dear children? Right. Similarly, I power 4. How can you write? I power 4 into I. Can I split it or not? As two factors. So what is the value of I power 4? 1 into I. Finally, we get I. Similarly, I power 6. I power 6 can be written as I power 4 into I square. Isn't it or not, my children? What is I power 4 value? 1 into, what is the value of I square? Minus 1. 1 into minus 1? Minus 1. Understood this value, my children? Right. Similarly, I power 7 is equal to I power 4 into I cube. What is I power 4? 1 into, what is the value of I cube? Minus I. 1 into minus I. What will you get here? Minus I. Understood these values, my children? All these values are based on these 3 points. I square, I cube, I power 4. Okay, my children. I power 8 and so on. Okay, my children. For I power n, to find the value of I power n, whatever the number it is, n, divide n by 4. First divide that n, whatever the exponent is here, divide that number by 4. Now, use these results. If n is evenly divisible by 4, then I power n is equal to 1. If you divide that n, if you get remainder 0, then write I power n value is 1. Understood, my children? If the remainder is 1, by dividing this number n by 4, if you get remainder 1, then I power n value is I. Okay, my children? Like this, you understand these values. The remainder is 2. If the remainder is 2, I power n is equal to minus I. If a remainder is 3, then I power n value is minus I. Understood these points, my children? Apply these rules here. You get the same result. Understood these points, my children? Right. Now come to the representation of complex numbers. How do you represent a complex number? Okay, my children. For a real numbers a and b, here a and b are two real numbers. The number a plus bi is a complex number. Then this is called a complex number, where a and b are real numbers. Okay, my children, if you observe this number, there are two parts. This is the first term, this is the second term. So this first term is called a real part, and the second term is called imaginary part. There are two parts in a complex number. Namely, first part is called real number, real part, and the second part is called imaginary part. Remember these points, my children. Okay, my children? Right. If b is equal to 0, b is equal to 0, then what will you get here? The second term 0. The complex number reduces to a. Isn't it or not, my children? This number reduces to a, which is a pure real number. Then the complex number is a pure real number. Understood this point, my children? Right. Similarly, if a is equal to 0, if a is equal to 0, if real part is 0, then the complex number reduces to bi. Isn't it or not, my children? 0 plus bi. What will you get to bi only? So Bi, which is called a pure imaginary number. Then the complex number is said to be pure imaginary number. Understood these points, my children? Right. In other words, all numbers, real and imaginary, are in the set of complex numbers. Understood, my children? Every number is included in the complex numbers, real and imaginary. A complex number is represented by like this form a plus ib. Okay, my children. The combination of real and imaginary numbers make up the complex number system. So here, see here, this is called a real part, the first term, and the second term is called imaginary part. The second term which contains I, this is called imaginary part. Understood this representation of complex numbers, my children? Right. Now come to these points. All numbers can be expressed as complex numbers. Every number can be expressed in the form of a complex number. Okay, my dear children, what is the form of a complex number? Yes, a plus ib, where a is said to be real part and bi, the second term, is called imaginary part. Suppose a number 3 is given. How can you represent as complex number 3 plus 0i? Isn't it or not, my dear children? Right, it has two parts, real part and imaginary part. But here imaginary part is 0. Understood this point, my children? Right, now come to minus 6i. This is a purely imaginary number. This also can be represented as a complex number, 0 minus 6i. Here also we represented this pure imaginary number as a complex number. Complex number means there should be two parts, real part and imaginary part, where here real part is 0 and imaginary part is minus 6i. Understood these points, my children? Right. Now come to the conjugate complex number. What is the conjugate of a complex number? The complex conjugate of a complex number, z is equal to xi. Suppose z is equal to xi is a complex number. Then its complex conjugate, the conjugate of this complex number z is denoted by z star or sometimes z bar. Okay, my dear children, remember these notations of conjugate of a complex number is given by z bar is equal to x minus iy. Understood this difference, my dear children? This is a given complex number and its conjugate is denoted by z star or z bar is equal to x minus iy. So we write the real part as it is, just we change the sign of the imaginary part. Then we get the conjugate of the given complex number. Understood this point, my children? Right. Next, two complex numbers. Suppose two complex numbers a plus ib and c plus di. If two complex numbers are given such that they are equal. If two complex numbers are equal, then automatically their real parts are equal. Similarly, imaginary parts also. What are the real parts here? Here real part is a. In this complex number, real part is c. So a is equal to c. We can write like this. Similarly, what are the imaginary parts? Here b and d. So b is equal to d. These are also equal. Understood this property, my children? This is one of the properties of complex numbers. Now come to the properties of complex numbers. The following properties of real numbers hold for the complex numbers also. Whatever the properties of real numbers are there, the same properties can be applied for complex numbers also. What are the properties? Associative properties of addition and multiplication, commutative properties of addition and multiplication, distributive property of multiplication over addition. All these properties we have studied in the case of set of real numbers. We can use the same properties for complex numbers also. Understood this point, my children? Right. Now come to the complex plane. You have already studied coordinate plane, xy plane, Cartesian plane. So for complex numbers also we use the a plane. That is also just like coordinate plane, xy plane, Cartesian plane. So we modify the familiar coordinate system by calling the horizontal axis as a real axis and the vertical axis is the imaginary axis. Here also we use the x-axis and the y-axis, but we call the x-axis as the real axis in this complex numbers, and the vertical line y-axis is called imaginary axis. Okay, my children, just we rename this axis. Okay, my children, understood this point. So each complex number a plus ib determines a unique position vector with the initial point origin 0, 0 and the terminal point a, b. Just like coordinate system, x coordinate, y coordinate, we can represent a unique position in this complex plane. Okay, my children, understood this point. Just we connect the knowledge of coordinate system, coordinate plane with this complex plane. Okay, my children, right. See this one, graphing in the complex plane. If a complex number is given, how do you represent that complex number in the complex plane? Suppose minus 2 plus 5i. See here, here minus 2 here, minus 2 comma 5. Okay, my children, just like this is, assume that this is x coordinate and this number as a y coordinate, minus 2 comma 5. So we represent this complex number in this plane like this. Similarly, my 2 plus 2i means ordered pair 2 comma 2. Imagine it as a ordered pair 2 comma 2. It lies in the first quadrant 2 comma 2. Understood this point, my children? Right. Similarly, 4 comma minus 3. Imagine it. It is an ordered pair 4 comma minus 3. How do you represent? Here 4, here minus 3. This is the position of the complex number 4 minus 3i in this complex plane. Similarly, take this number minus 4 minus 3i means ordered pair minus 4 comma minus 3. Understood these points, my children? Just we use that Cartesian plane knowledge here. First number, real part is considered as x coordinate and imaginary part is considered as y coordinate. Just to remember that points. Okay, my children? Right. Now come to the absolute value of a complex number. How do you find the absolute value of a complex number? The distance of the complex number is from the origin on the complex plane. That is called absolute value of the complex number. You know how to represent a complex number in the complex plane. Then the distance of the complex is said to be absolute value of the complex number. If you have a complex number a plus ib, suppose a complex number a plus ib is given, then the absolute value can be found by using this formula, square root of a square plus b square, means square root of x coordinate whole square plus y coordinate whole square. Understood this point, my children, how to find the absolute value of a complex number, right? For example, see here modulus of minus plus 5i. How can you find the absolute value of this complex number? This is a notation, modulus. It is a notation for absolute value of the complex number. This is a notation. Remember this one. Square root of minus 2 whole square plus 5 whole square. Because here minus 2 is real part and 5 is the imaginary part. Okay, my children? Right. Then we find square root of 29. This is the absolute value of this complex number minus 2 plus 5i. Similarly, let us take this example, modulus of minus 6i. Minus 6i is a given complex number. Then here a is equal to 0 and b is equal to minus 6. Do you remember this my points, my children? How to compare the given complex number with a plus ib. Okay, my children, then we get square a is equal to 0 and b is equal to minus 6. In this formula, we substitute a and b, then finally you get 6 here. This number is said to be absolute value of this complex number. Understood this point, my children? Right. Now come to addition and subtraction of complex numbers. How to add and how to subtract two complex numbers. We use the same as algebraic expressions. Okay, my children, add or subtract the real parts and then add or subtract the imaginary parts. This is the rule to addition or subtraction of complex number. Suppose, for example, a plus ib and c plus di are two complex numbers. Then a plus bi plus or minus c plus di is equal to a plus c. We have to add real part plus or minus b plus di. Understood this point, by children? Similarly, in a subtraction also. For example, c 4 plus 6i plus 3 plus 7i. What are the real parts? 4 plus 3 plus what are the imaginary parts? 6 plus 7i. Finally, you get 7 plus 13i. Here, print mistake is here. 7 plus 13i. Understood this example, my children? Similarly, here, subtraction. 10 minus 5. What do you get? 5. Minus 4 minus 2. What will you get here? So, minus of minus plus 2. 4 plus 2, 6i. Understood this addition and subtraction of complex numbers, my dear children? Right. Up to this point, my dear children, here multiplication of complex numbers. Here also, to multiply two complex numbers, we follow the rules how to multiply two polynomials. Here also we follow the same rule. See example 1, minus I into 3 plus I. Minus I into 3 plus I. So we multiplied 3 plus I. Two terms are there within the brackets. Outside the brackets, minus I is there. So we multiplied the two terms within the brackets by minus I. So minus I into 3. What will you get here? Minus 3I. Plus into minus I square. I into I square. Okay, my children. That is equal to minus I minus, I square value is minus 1. I square value is minus 1. So minus of minus 1. So minus of minus 1, what will you get here? 1. So 1 minus 3i. This is product of these two complex numbers. Now see the example 2. 2 plus 3i. 2 plus 3i into minus 6 minus 2i. Here also we have to multiply these two expressions. Just to imagine these are two algebraic expressions. Imagine these two are two algebraic expressions. So how do you multiply two algebraic expressions here? Within these brackets, two terms are there, and within the second small brackets there are also two terms. So we multiply these two algebraic expressions. Just imagine there are two algebraic expressions. So how do you multiply 2 into minus 6? What will you get? Minus 12. 2 into minus 2i, minus 4i. 3i into minus 6, minus 18i. 3i into minus 2i, minus 6i square. Okay, my children? that is equal to minus 12 minus 8 minus 4i minus 18i. By simplifying these two like terms, these are like terms, we get to minus 22i minus 6 into, again here I square, we got here I square means minus 1, so we substituted minus 1 in the place of I square, we wrote minus 1. So minus 12 minus 22i minus 6 into minus 1, we get plus 6. So again minus 12 and 6, these two are like terms, these two are like terms, constants. So minus 12 plus 6, what will you get here? Minus 6 minus 22i, minus 22i. Understood this multiplication of complex numbers, my dear children? There is nothing special in the complex numbers, my dear children. The entire chapter, throughout the chapter, just remember that I is equal to square root of minus 1, or I square is equal to minus 1. I is equal to square root of minus 1, or I is equal to, I square is equal to minus 1. That's all. The remaining part is same as that of algebraic expressions. Okay, my children. I's like variables, then change any that are not to be first power. Okay, for example, see here a plus bi and c plus di are two complex numbers are given. So to multiply these two complex number a plus bi into c plus di. Okay, my children, just use that properties. How do you multiply the two algebraic expressions? We follow the same rule here also, my children. Remember these points. No need to think about other concepts. Okay, my children. Right. So the product of two complex numbers is found by multiplying as if the numbers were binomials and using the fact that I square is equal to minus 1. So assume that the given two complex numbers as binomials, 2 plus 3i into minus 6 plus minus 2i. Just like how do you multiply two binomials? Use the same property here also. Understood this concept, my children? Right. Suppose if you want to divide a complex number by another complex number, 3 plus 11i by minus 1 minus 2i, then we have to recall that previous knowledge of rationalizing the irrational numbers. So like here minus 2 minus 2i is there. Multiply the numerator and denominator by minus 2 plus 2i. Understood this concept, my children? Just assume that this is a rationalizing factor of minus 1 minus 2i. Just it is nothing but a conjugate of this complex number. If a fraction is given in the complex numbers, then we have to convert the denominator as a real number. To make this denominator as a real number, we have to multiply the numerator and denominator by its conjugate complex number. Then we follow the as it is, as we are multiplying the binomials in numerator as well as in the denominator. Then automatically it converts like this, minus 5 minus I. You get two parts, real part and imaginary parts. Understood this concept, my children? Right. Yes, my dear children, have you watched the video completely? Only Catherine and Ria responded. What about other children? Yes, Mahima, Easter, only 4 children. Melam, Richard, also. What about Rexlin, Nikhil, Disha Priya. Have you not watched the video? Have you not watched the video? Disha Priya. Disha Priya and Nikhil. Not watched the video? Percy, have you not watched the video? Yes. Then why didn't you reply to my question? Why didn't you reply to my question? It's okay. It's okay. Now, after watching the video, all of you open the textbook at page number 97. All of you open the textbook at page number 97. All of you go through the pages 97, 98, 99, 100, 101, 102, and 103. All of you go through these pages in the textbook. Now, all of you go through these pages from page number 97, from page number 97 to page number 103. Page number 97 to page number 103. Now go through all these pages. Now itself, my dear children, I will ask you some questions on these pages. 10 more minutes are there. 10 more minutes are there. Please go through these pages. My dear children, go through these pages. Are you opening the textbook? Open the textbook, my dear children, and go through the textbook now. You have to prepare the classwork notes by yourself by reading these pages. By reading these pages. Okay. Please carry on, my dear children. Read the textbook. Don't leave the meeting, my dear children, till 3 past 15 minutes. Only 10 more minutes are left. Only 10 more minutes are left. For these 10 minutes, please read the textbook from page number 97 to 103. Please carry on, my dear children. If there are any doubts in these pages, ask your doubts and get your doubts clarified. Okay, my dear children. Tomorrow we will start exercise problems. So, in the meantime, read these pages well and understand the concepts given in these pages well. Okay. Yes, my dear children, now the time is 3 past 16 minutes. Have you read the textbook? Have you read the textbook? No one is responding. Yes. Okay, my dear children, before attending the class for tomorrow's class, please read these pages well. We will start exercise problems and prepare the classwork notes by yourself. Okay. Now you can leave the meeting, my dear children. Take rest. Take care of your health, my dear children. Stay at home. Stay safe. Sanitize your hands frequently. Yes, thank you all, my dear children. Thank you all.